Mario Galaxy, you've deceived the people with Dusty Dune Galaxy not once, not even twice, but thrice! First with tornadoes, now with the climate, and with its quicksand? Today I'm exposing your lies once and for all. Dusty Dune Galaxy, my least favorite galaxy in the original Mario Galaxy. I keep finding more reasons to dislike this place, and the blatant inaccuracies regarding weather conditions only adds fuel to the fire. Last time I went here, I was talking about the tornadoes, which ended up being dust devils. Today, I'm discussing the cause of many a player's death in this galaxy: quicksand. Many think of quicksand as a geology concept, but it wouldn't be able to form without some form of water, which comes from rain, especially if it sits after a storm concludes rather than evaporating or from a stream that's flowing. The climate Dusty Dune is in must allow for this to happen, else we wouldn't get it at all. This isn't exactly weather in the traditional sense, but it does form due to it, so I have some grounds to discuss it, at least I like to think so. Quicksand forms when we have a mixture of small, fine materials, such as sand, silt, and clay, and water. It forms when these small, fine particles are saturated and agitated by some outside force, such as a person walking through it. In other words, this occurs when water in the particles of sand, silt, or clay cannot evaporate or escape through other means. This results in the creation of a liquefied soil that is thereby weak and unable to support most any weight. When sand is in this state, nearly anything that enters it is likely to sink, getting lost into the abyss, never to be seen again. Or so many media sources would lead you to believe. In Mario Galaxy, if Mario so much as touches this deadly sand, he loses a life instantly, having no time to save himself. This is hardly the only source of media to depict quicksand in such a way. Many movies depict quicksand as this life-threatening thing. One example that comes to mind is The Princess Bride. One scene depicts Princess Buttercup immediately sinking into quicksand and disappearing, and Wesley jumping in after her. They do survive, though gasping for air as they climb out of the sand via a vine. Another example that comes to mind is Wreck-It Ralph, when Fix-It Felix and Sergeant Calhoun get stuck in Nez quicksand, a fantastic pun if I do say so myself, and they use Laffy Taffy to pull themselves out of it. In both instances, and in many other films and shows, this is usually how quicksand is portrayed. They love to portray it as something that's deadly and could easily cause loss of life if you get stuck in it. Mario Galaxy's portrayal of this is what I'd call an extreme depiction of this idea, where Mario loses a life pretty much immediately after touching it. You might have the same question that I did. Just how accurate is this? Is it possible for quicksand to swallow people up whole this quickly? This seems relatively simple. Quicksand, being unable to hold any weight on its surface, should cause a person to sink rather quickly. Yet something was bugging me about this. Something big. I couldn't figure out why at first. I was looking at these instances, especially Mario sinking so quickly, and something didn't feel right. So I thought about it. I really thought about it, and went to verify if my thoughts were simply in the realm of wishful thinking or scientific fact. Despite my suspicions, I am still surprised at what I learned about quicksand. I've spent some time learning about what happens when the ground is saturated. Usually this results in flooding, a deadly consequence of heavy rains most of the time, that us meteorologists warn people about. When it comes to sand and similar fine particles being saturated, however, this acts a bit differently than if we're dealing with dirt or pavement. Dirt will hold as much water as it can until it becomes saturated, then runs off top of it, the beginning stages of flooding. Pavement can't absorb water at all, so it just runs off. What about sand and other similar particles, though? They act differently from these. It doesn't necessarily run off or get absorbed into the ground. Fine particles, especially sand, tend to be water-loving molecules. You could say water and sand go together like peanut butter and jelly. When water hits the sand, it causes it to stick together rather than being individual particles. This happens because of the surface tension of the water in between each grain of sand. The water that sticks to the sand builds bridges between the water on other sand particles, forcing the sand together. This is the wet sand we can commonly find at beaches at the water's edge. It's also great for building sandcastles and various other sand structures. Fun fact, I once went to a competition where they were building sand sculptures based on a certain theme, and the only reason they were able to have this competition at all is because sand is moldable. This is why we sink into it when it's wet, but sinking into wet sand is not necessarily the same as sinking into quicksand. What differentiates quicksand from your average wet sand you'll find at the beach? It really comes down to water composition. Wet sand, while it's wet, is only comprised of 25% of water on average. Quicksand, on the other hand, can be comprised of up to 70% of water. That's a major difference in water composition. To give you a semblance of comparison, the human body is comprised of at least 60% of water, meaning quicksand can have more water than the body. Given their differences in water composition, wet sand acts more like a solid no matter what way we slice it. Sure, you sink a little. Going to the beach, we see this if we're walking along the wet sand versus the dry sand. We sink into wet sand a little, usually our footsteps leaving imprints in the wet sand unless they're filled in again. This is nothing compared to quicksand though. Quicksand has the appearance of being solid, but if something too heavy is placed on top of it, it acts like a liquid, allowing things to pass through it. Since its composition is mostly water and only a little bit solid, this makes sense. Humans may be able to float in water, but we're dealing with a solid and liquid combination here, which acts differently than pure water. This makes me question if it's truly possible for us to sink so low that our head goes under in quicksand. I had a theory that this sinking may be a tad over-exaggerated in media as a way for them to create drama. So I went digging. As it turns out, assuming we believe the Mario movie, and that Mario is a human like we are, it should be completely impossible for him to become fully submerged in quicksand. Yep, we've been deceived this entire time. It's impossible for a person to become completely submerged in quicksand. Don't worry, I'll explain why. We can't entirely sink in quicksand, and neither can Mario because we're less dense than quicksand is. To give you an idea of how density works, think of a body of water. Say we have a stick and a rock. Water has a density of 1 gram per cubic centimeter. Anything with a lower density than that will float, and anything with a higher density than that will sink. If we place a stick in water, it floats because it's less dense than the water it's sitting in. A rock, on the other hand, will sink because it has a greater density than water, thus preventing water from holding it up. When it comes to a human's density, we already know that it is usually lower than water's density of 1, because people are capable of floating in the water. Now, the average density of a person is 0.98 grams per cubic centimeter. Keep in mind that this number may vary based on several factors like height, age, weight, blood type, and many other things, but this is generally the accepted value for the average. So why do we sink in water? Well, to put it bluntly, a lot of it has to do with muscle. Muscles are generally denser than water, but our fats that we store are less dense than water. This results in the interesting phenomenon where humans can both float and sink. Quicksand works similarly to water. On average, quicksand's density is around 2 grams per cubic centimeter. I think you can see what's happening here. Quicksand's density is simply too high for us to become fully submerged. We still sink, but it won't go beyond our waist height. You definitely still need some help to get pulled out of quicksand, sure, but you aren't going to become fully submerged in quicksand. In fact, very few deaths that are due to quicksand are because someone was submerged. It's far more common that dehydration or even hypothermia can result in fatalities rather than a fully conscious person sinking partway into quicksand. Frankly, given quicksand's unique nature of acting as a solid unless the force is too great, even objects with higher density may not sink in quicksand if the object is stationary. On top of all of that, this galaxy shouldn't even have quicksand to begin with. For quicksand to form at all, it decidedly needs water. I don't know about you all, but it's bone dry here to me. I don't see any evidence of sitting water. This place doesn't seem to be a marsh, a riverbank, a beach, or any other place where quicksand would typically form. Heck, even Shrek would have a better chance of getting quicksand where he lives in a swamp. At least there's standing water there. In the desert, that just isn't there most of the time. It's actually rare that quicksand forms in deserts at all. Usually, desert sands are just too tightly packed for quicksand to form. If quicksand was going to form here, it would have to be under extremely specific circumstances, like it forming on the downwind side of a dune. It definitely wouldn't encompass the entire galaxy though, even in that case. So, why is this quicksand here? Is this quicksand just quicksand? Unfortunately, I hate to break it to us, but it's probably the classic reason I use if things don't make sense and I can't think of any other logical explanation. It's a classic. Nintendo logic. Thank you all so much for watching. If you enjoyed the video and want to see more content like this, be sure to subscribe. I have more on the way. I will see you all in the next one. Have a good day, everyone.